Hi, I'm Ryan, and we're debunking problem number 4 on our group project for quantitative reasoning. Our group members include myself, Ryan, Vesna, Cody, and Autumn. Imagine a game where you want to get the highest number when rolling a die. You can either stay and keep your next roll, or roll again to do better. What to expect on the first roll? On the first roll, the expected value is 3.5. How you get 3.5 is by adding all the numbers together, 1 through 6, which are the possibilities of what you could get when you roll. So 21 divided by 6 is 3.5. On average, if you roll higher than a 3.5, you should stay. So that means on your first roll, if you get a 3, you want to switch because it's not higher than 3.5. But if you were to get a 4, you'd want to stay because the likelihood of you getting more than a 4 is impossible.
What to expect on the second roll? On the second roll, the expected value is 4.25. You get that number because instead of having 1 through 3, your new value that you need is 3.5. So you add up all the numbers, including 3 3.5s, 4, 5, and 6, and you get 25.5. You divide that by 6 for the sides, and you get 4.25. So essentially, if you get any number that is lower than a 5, you should switch. But if you get a 5 or a 6, you should stay. What to expect on the third roll? Essentially, you're going to use the same procedure that you did on the second roll, except for now your new expected value is 4.6. You get that number by adding up 4.25 4 times, as well as 5 and 6 to get 28. 28 divided by 6 is 4.67, so that's your new expected value. So essentially, if you get anything that is lower than a 5, you should switch.
If you roll a die 1,000 times, you should only stay when you have a 6. So what's the smallest number of allowed rolls for which you only stay when you roll a 6? We completed the problem the same way that we completed the first through third rolls, and on the fourth roll, you have an expected value of 4.95. So on any time you roll a 5 or a 6, you should stay. On the fifth roll, the expected value is 5.13. So anytime you roll higher than a 5.13, you should choose to stay.
This concludes our brief battle plan on how to become champions of the dice using quantitative reasoning to improve our odds at winning the game.